Hi, hello, good evening everyone. Welcome to the session. Welcome to Gradeup. We are with NIELIT Toppers 2020 video series. I welcome you all for the session. I know you are all eagerly waiting for the session. So this is Satya Narayana, senior faculty from computer science. I have 13 plus years of teaching experience. Before we get into the session, guys, please let me see how many joined the session. Okay, so I can see Rajan, good evening. Rukmini, hi. Kirti, good evening. Right, so guys, please join the session quickly. I'm waiting for you all. So today we will be starting this NIELIT Toppers video series for 2020 aspirants with the subject computer networks. Here you can see this. Today we will start with computer networks, in which with the topic error control. Okay, so before we get in, guys, again a quick reminder for you all, as we are all terribly worried about this coronavirus. Here is one reminder about how to wash your hands. So please observe the things, like you have to follow these basic steps while washing your hands. Like first wet the hands and then apply the soap, then rub hands, and in between back of your hands, in between the fingers, okay, and even the thumbs, nails. So all these you have to wash carefully, and then only you dry with a single use towel. Then you try to use another towel to turn off the tap. Okay, so please follow these precautions, guys, while washing your hands. Please apply this procedure, and then if for any assistance, don't be panic. Gradeup will be always with you, and you can just reach this toll-free number 9111-239-78046. Okay, so let's get into the session, guys. So it is about me. So as I told you earlier, I am with 13 years of experience in teaching for GATE, ISRO, bar kind of exams, as well as NIELIT, of course. And I have mentored more than 10,000 plus students across 15 plus cities. I am PhD scholar, GATE qualified, CISCO certified, and SET qualified too. Okay. So guys, today we are with this error control topic. Before that, as you all know, computer networks, which is a very important topic in either GATE or ISRO or bar kind of exams. Even in NIELIT also, this is considerably important subject, we can say. And the complexity of the questions, you can say they will be very easy questions, guys. You will get in the NIELIT, or you will get direct questions. Easy or direct in the sense, simple formula based questions you will get. And this is common, this subject is there, common for both Scientist B and Scientific Technical Assistant A. For both, this subject is common subject. Now, if you look at the syllabus of this computer networks, for Scientist B, we have ISO model, LAN technologies, flow and error control, routing algorithms, congestion control, TCP, UDP sockets, IPv4 with IPv6, application layer protocols, basic concepts of network devices like switch, router and all, wireless technologies, basic concepts of cryptography, digital signature, firewall kind. And if you observe for scientific or technical assistant A, this one, you have the same here, plus indicates all these topics are there even for scientific assistant B also. Along with this, you have user authentication, token based authentication, biometric authentication, remote user authentication. So basically here authentication is the topic extra addressed here, and then intrusion detection systems, like you can say honeypots, denial of service DOS, wireless networks, in which we will be we need to have basic idea about at least this 2G and 3G networks, 2G and 3G networks, as well as Bluetooth. So for STA we have little more topics in CM. And if you look at the weightage from the past papers, this is the weightage I have extracted, guys. For scientist B, from this computer networks subject, you can expect the weightage. You can expect the weightage as 6 questions, and for scientific assistant A, 5 questions. Yes, of course, guys, this is from the previous year question papers. Previous, like in the 2018, 2017, 2016 also, the NIELIT has conducted exam for the same post, scientist B and scientific assistant A. From those papers analysis, this is what the weightage I have extracted. But as per the syllabus that we have seen for 2020 jobs, the weightage, I can say considerably, you may expect little less weightage from this and little more weightage for scientific assistant B or scientist A. Okay, I hope you understood what I am telling. So this time you can expect maybe like exchange of this weightage, guys. You can just expect the exchange, like for scientist B you may expect 5 questions, for scientific assistant A 6 questions. Okay, I hope you got about weightage from this subject. And then error control, this is the topic which we need to address. So before I go ahead with this topic, guys, I request you all to please like the session, share it to all of your friends. Let all who are aspiring for NIELIT benefited out of this session, and please do subscribe to our Gradeup Gate channel without fail. Okay, so shall we start, guys? Could you please mark your response? Shall we start? Yes. Okay, guys, in computer networks, what is actually error means? We know there will be a sender who will transmit the data. Let's say A is the sender who is transmitting the data to the receiver B. Gaurav, whole syllabus, yes, definitely will not be completed in this series. Okay, definitely whole syllabus cannot be completed, but we will try to pick some topics and we'll try to give the model question, not model questions, the previous questions and expected questions. Okay, Gaurav, is there paid course? Yes, there is a paid course. Actually, we are planning for that. The details you will get to know. Everybody will get to know. So please do subscribe to our channel for getting the timely notifications, and do download our Gradeup app. Okay. So guys, when we say the transmitted data which A transmitted to B, when it is not equal to the received data, then we call it as error, right? So when the transmitted data is not equal to received data, this is what we call as error. This error is basically two types we can say. This error we can say basically of two types: single bit error and burst error. As the name indicates, single bit error when there is only one bit change in the sent and received. Burst error, more than one bit change. So if suppose 110 is transmitted, 1101 is received. So here this is the bit which is changed, or 1110 is received. So this is the bit which got changed. Like this, any one bit got changed from the sent to received, that is called a single bit error. And if more than one bit got changed, like you can say when 1100 is transmitted, 0111 got received, then we can say it is a burst error. So either for single bit or burst errors, to handle these errors, we have got techniques which are classified into these types. So the error handling codes are basically classified into two types: error detecting codes, error detecting and correcting codes. And error detecting codes and correcting codes, what is the difference between this? Error detecting codes only find presence of an error. Whereas error detecting and correcting codes will find out both presence and position also. What, Ravi? What marks could we get from this series while you are not covering the syllabus? Ravi, within the time duration, we are trying to do what best we can do. Okay, as every day we are planning for only 1 hour. So let's see how much best we can do. Initially, we are planning to cover few important topics from main subjects that about this series, what we are going to cover and all. In the last session, I have already explained you all clearly. So if you still have what topics we would be covering in this series, please, I request you all to please refer that, which is all about NIELIT 2020. In that session, I have clearly explained what we are going to cover in this series, and if time permits, definitely we will give more. See, only one subject completely 100%, even if we teach also, that won't benefit you, because there are many subjects which you should know, which you should learn. Like from computer networks, you will be getting either 5 or 6 marks. So even if you completely, even we teach, we are giving you 5 or 6 marks, right? So in the time frame, within the possibilities, we are trying to cover what best we can cover. If time permits more, definitely we will give you even more. Okay. Yes, there will be playlist for these videos. Okay, guys, I'll answer all your doubts. Yes, this is the first class. I'll answer all your doubts. If you hold for a moment, let me go ahead. Then I'll answer all your doubts. Okay. So the difference between error detecting and correcting code is detecting code only can find whether there is an error or not, but it cannot find which bit is error or how many bits are errors. If you see detecting and correcting code, it can find presence, means whether error is there or not, and where that error is, position also. And if you see, these are subclassified into vertical redundancy check, longitudinal redundancy check, cyclic redundancy check, and checksum. And detecting and correcting code is subclassified into Hamming code. Okay, Hamming code. Then, if we quickly, I don't take much time, guys. I know you're all waiting for kind of questions for practice, what kind of questions we may get. And why I am giving the theory part means because there may be some ECE students or non-CS students, because not only BTech CS are eligible, right? So there are many branches which are eligible for this NIELIT. So keeping all in mind, I am again quickly revising the theory part. So the students who already know these concepts, please have patience for some time. Let all know the things. Then definitely before I sign off the session, definitely I'll give you questions on this topic. Okay, I hope you got it. So this vertical redundancy check is what simply we call as parity mechanism. We know what is parity means: the number of significant binary digits, that means the significant bits in the code word are called parity. What is the code word? Suppose what sender wants to send is data word, but for controlling the errors, sender will add some redundant bits or check bits, we call this as. Then whatever obtain, that is called code word. Okay, whatever obtain, that is called code word. So what is a parity? Basically, how many significant binary digits in the code word. For example, I would like to make the number of significant binary digits means ones a even number, then that would is called even parity. For example, the data word D is 1101. How many number of ones? 3 ones are there. So to make this number of ones as even number, I'll put one more one as redundant bit. So what is the code word? 110111. 11011. So total number of ones now became 4. So this is called even parity. And what is odd parity? The total number of ones should become odd. So if this is the data word sender wants to send, now the redundant bit would be 0, because to keep it odd number of ones, what is the code word sender will send? 11010. Now once it reach the receiver, what parity sender follow? The same parity receiver follows. So here what is the condition? Sender and receiver should follow the same parity, even parity or odd parity. This is one condition. But there is a drawback of this particular mechanism. What is that drawback? If there are 2 bits change, 4 bits change, 6 bits change, then this parity cannot detect. So we can say when there are odd number of bit errors, then only these can be detected. If there are even number of bit errors, they cannot be detected. I'll show you one example here. See this. Suppose sender is following even parity. This is what sent. But receiver received this one. So what receiver do? Receiver count the number of ones. It is still even number. So what receiver think that? As the receiver is finding same even parity, receiver feel like no errors, but here you can see these 2 bits are errors. So like this, when 2 bits change, 4 bits change and so on, then definitely this kind of parity cannot detect. That is the drawback. Okay. And if you see longitudinal redundancy check, what is this longitudinal redundancy check? The mechanism is what sender wants to send, let it be data word. First, the data word is splitted down into blocks of fixed size. Okay, this is the first step in LRC. Then we will arrange these blocks line by line, and we will calculate the parity column wise. We'll calculate the parity column wise. Then whatever the parity that you got, that is what redundant word or check bits. So let us have an example. Let us say the data word sender wants to send is 10110110 like this. Let's say the block size is 4. Now, what sender will do? First data word is splitted. And it need not to be exactly multiple of 4. Let's say consider like this. There is one more one. So we will say the block 1 is 1100, this one. Block 2 is 0110. Block 3 is 1011, and block 4 would be 0001. Observe, in this block 4 only 1 bit is there. So we know how to make it 4 bits. Now this is what the second step means. Arrange the blocks line by line, then calculate parity column wise. Here you may follow either even parity or odd parity. But what parity sender follow? The same parity receiver should follow. Let's say the sender is following odd parity. Then this would be 1, 1, 1, 1. So this is what R. Then what is the code word sender will send? 11011 0110 1100 1111. Receiver also follow the same If he get any non-zero redundant bits, he will find there is error, otherwise no error. So the longitudinal redundancy check is better compared with the VRC, but it also cannot detect all kind of errors. It can't detect all kind of errors, but compared with VRC, this is better. Now if you move on to next, checksum. What is checksum? Checksum process is also simple. The same step for as in the LRC. What data word is divided into fixed size blocks. The first step is this. Then let's say these blocks be B1, B2, B3, B4, so on. Now what we will do, B1 is exclusive OR with B2. Whatever the obtained result, let it be sum 1, S1. That S1 is exclusive OR with next block. Whatever obtained, that is called S2. This is exclusive OR with the next block, S3. So until all blocks are over, we do this process. Let's say the finally obtained sum is Sn. Okay. Now we have to do complement to this sum. Whatever obtains, you may do 1's complement or 2's complement. Okay. But what complement sender do, receiver also do the same. So whatever obtained, this is what redundant word. Okay. Now, guys, I am watching all your doubts, but just after this checksum, I'll take all your doubts. Just a moment, please. Now, let's see one example. I don't take big ones. So let the data word D is equal to 1101, 101, 0101. So first what we do, divide into blocks. Let the block size be 4 bits. Let the block size be 4 bits. So this is B1, this is B2, and this is B3. So what we do first, B1 and B2 we do XOR. So this would be 0101, 1011. So what this would be, 0111. For this, do XOR the next block. So that would be 1101, 1100. Now do complement. Let's say I am doing 1's complement. So what would be coming? 1100 would be coming. So this is what R. So this is appended. This is appended to the D. So what is the code word? We can say 1101, 1011, 0101, and then followed by R. So this is all data word followed by R. So this becomes code word. Receiver also do the same. If receiver get anything different than this code word, whenever he do the same process, divide into blocks, get the consecutive sum, and whenever he check that sum, if he get 0 for receiver, so for receiver, if the result or the final sum is equal to 0 means no error. Otherwise, if any non-zero result tells there is an error. So this is what checksum procedure. Okay. Then CRC. To understand the CRC, guys, definitely we should all understand this minimum XOR operations, parity, error, all this stuff. Okay. Now, before I move on to this CRC, let me take the doubts from the students. Couple of doubts like. Shivam Singh, देखी okay English tricks देखी कंप्यूटर टीचर या KBS कंप्यूटर टीचर के लिए कोई पेड कोर्स डिजाइन करे प्लीज okay English trick as a faculty, as a teacher, you are all my students, you are all equal to me. Keeping all in mind, I have to teach. I understood your frustration, I think, but still I am going from scratch, I know, but still I am not taking much time for every topic, guys. Please understand, have some patience. I'll take you to the questions just in a moment. Maybe in 10 minutes I'll be taking you to the questions. Okay. Shikhar Saxena, sir, is theory of computation in the syllabus this time? No. Shikhar Saxena, this time TOC is not there for NIELIT, either for Scientist B or for STA. Done. Kavya was asking, sir, why we divide block from right hand side? Kavya, that is what we have to do in binary, because in binary, leftmost zeros do not carry any weight. So whenever you are dividing, let us suppose like this, when you start dividing from this, here there are no 4 bits. So here you will, if you put 0, this is wrong, because this is changing the value. So that's why if the same 1101 is there, I mean the same, you should start dividing from like this. Here you put 0, this is correct. So that is what the trick in binary. We always start division from leftmost, that means from units place. I hope Kavya you got it. Okay. Himadrika Sinha, good evening. Saurabh Kumar, good evening. So I can see many of my old students. Good to see you all again. कंप्यूटर टीचर के लिए कोई कोर्स डिजाइन कर रहे हैं क्या आप? कंप्यूटर टीचर, which computer teacher? Is there any such job? I did not get you. Okay, feel every bit. Sir, is calculator allowed in the exam? No. No guys, this is an offline exam and calculator is not allowed. But don't worry, simple calculations you may need to do, but you need to practice. Just because of that, don't neglect. You need to practice. Mainly direct questions will come, easy questions will come, and formula based questions will come. Calculator is not allowed. Okay, so English tricks currently as per my knowledge, we are not planning for any TGT, PGT course. I believe you were talking about that, trained graduate teacher or primary graduate teacher, right? So for TGT or PGT course, currently as per my knowledge, we are not planning any course. Okay, I don't know in the future. Fine guys, so let's get into the session again for CRC. Guys, in the cyclic redundancy check, first let me write the algorithm or procedure. Okay, first there is a data word which sender wants to send. Okay, there is a data word and there is a divisor. CRC is based on division process. Guys, I am not going into details. I am trying to give you the alphabets of the topic so that even the other branch students also get the crisp. Okay, so the CRC basically is division based procedure. So let the sender has some divisor with small n bits. Then the sender has to form the dividend first, that is append n-1 zeros to data word. That is what dividend. Let it be D. Okay, or I can say let it be dividend. And you have to do division process. So you have to perform division. How means? Just you have to do exclusive OR between dividend and divisor. Dividend and divisor repeatedly. Until all the dividend bits are over. So finally you will be getting n-1 bit remainder. That would be your R. Okay. Fine. Let us see an example. Let us see an example of CRC directly with the question. Okay. Guys, this is what the question that we got in NIELIT 2018, as well as you have got the same question in GATE 2005 also. So at this time I can say NIELIT difficulty level is in relation with GATE 1 mark questions. Not all 1 mark questions. In 1 mark questions also you will have easy questions. So in that such easy questions category you can see this NIELIT difficulty level, guys. You can, this is the proof. In 2005 GATE, whatever the question you got, in the same question you got in 2018. Okay. Now, so what I just taught, let me try with this example directly. So this is what the message we got, and this is what the CRC divisor. Here what is the CRC divisor means? It is given in this form. Observe, x power 5 plus x power 4 plus x square plus 1. So this is called the polynomial representation. So how to do this? This is like 1 into x power 0, right? So we have to take the coefficients. So this would be 1. There is no x power 0 coefficient, x power 1 coefficient, sorry. So it would be 0, x square, x cube, x power 4, x power 5. So this would be the divisor. 1 1 0 1 0 1 would be the divisor. And this is what the data word we have. And what this is 1 1 0 1 0 1. So as this is having 6 bits, observe 1 2 3 4 5 and 6. So append 5 zeros, 1 2 3 4 5 zeros. Now do what? XOR repeatedly. So I am doing XOR 1 1 0 1 0 1. So this would be 1 0 1 1 1 0. What is XOR means? If same bits are there, output 0, different bits output 1. So now this, whenever this leftmost bit MSB is 0, shift left it and borrow the next bit. Okay, borrow the next bit. Now repeatedly you do this. That is what I said. So 1 1 0 1 0 1. So this would be 0 0 1 1 1 0. Now you can perform 2 shift lefts, provided you have to borrow 2 bits here. So this would be 1 0, you will be shifting. Now 1 1 0 1 0 1 0 0 1 1 1 1. So again 2 shift lefts and borrow 2 bits. This 1 I am borrowing now, and this is 0 I am borrowing now. 1 1 0 1 0 1 0 0 1 0 1 1. Again 2 shift lefts and borrow these 2 bits, guys. 1 1 0 . So what is that we got, guys? Oh my god, sorry. It's got erased by mistake. This would be 1 1 0 1 0 1. So 1 1 0 1 0 1. So let me do it quickly, guys. Then I am borrowing this bit. First I have added 5 zeros. Then 1 1 0 1 0 1 0 0 1 1 1 0. Then I would be shifting these 2 bits. Sorry, these 2 bits. 1 0 1 1 0 1 0 1 0 0 1 1 1 1. Yeah, so I can see somebody giving the answer. Guys, you also solve with me and give your answers, please. So then I'll shift these 2 and then I'll be borrowing this 1 0. So 1 1 0 1 0 1 0 0 1 0 1 1. I'll borrow next 2 bits. 1 1 0 1 0 1 0 1 1 0 0 1. So here I can borrow only 1 bit. So here let me write 1 1 0 0 1 0 1 1 0 1 0 1. So 0 0 0 1 1 1. Here I am borrowing only 1 bit because I have only 1 bit left for borrowing. So 1 1 0 1 0 1 1 1 1 0 1 1. So as the MSB is 1, we have to do this again. So this would be 0 0 1 1 1 and 0. So this is 0. So if you shift left, this is what we got, CRC reminder. So 0 triple 1 0. 0 triple 1 0 is the answer. Saurabh Kumar, you got something different. So the leftmost 0 we have to neglect because you have appended only 5 bits. Only 5 bit reminder would be coming. This is shifted left. Okay. Kavya, only zeros are shifted because the leftmost zeros do not have any weight. See, I am shifting only zeros. Here, though I have 3 zeros, observe, though I have 3 zeros, as I don't have bits to borrow, here what I have done actually, if you observe clearly, this is the bit I have borrowed, and these are the bits I have borrowed. So whenever I am shifting, I am borrowing the bits. So why I am shifting? For the vacant place in the register. Okay. So these zeros I have shifted like this, and this 0 I have shifted. and as there are no more bits to borrow, here we are, shift left we have done and we have seen bit to borrow, there are no more bits to borrow. Here the algorithm or the program ends. Finally, this is what the remainder we got. So what is the answer for this question? 01110. So this is what one CRC question which came in earlier NIELIT exam. As you can see, it is of gate 1 mark level. So let us again solve. Yeah, Saurabh, recheck once. It would be 01110. Okay, guys, let us solve another question of this kind. Yeah, guys, this is the question. If you please solve this, everybody try doing this. It would be like a practice for everybody. I know there are many students who have appeared for GATE, as it's been almost 1 month. So you might have got some gap. So let us recall the things, guys. So don't feel lazy. Here, this is the divisor we got, x cube plus x plus 1. And this is the message we got, 0101 1011. So what would be transmitted? So what is the code word? What you want? Code word is equal to what? So try. I will be waiting for you. You just have 30 seconds time, guys. Just do it and let me know your answer, please. Khan Bilal was asking how many bits to pad. How can know? Khan Bilal, I have padded 5 bits because in the divisor I have 6 bits. See this question, Khan Bilal. The divisor is given as x cube plus x plus 1. So what this means? 1 into x cube plus 1 into 0 into x square plus 1 into x power 1 plus 1 into x power 0. It is in polynomial form. So take only coefficients. That is how divisor will form. So what is the divisor? 1 0 1 1. How many bits are there? 4 bits are there. So how many bits to borrow? As the divisor has n bits, n minus 1 bits to borrow. So always remember, as the divisor has 4 bits, n minus 1, so 4 minus 1. Now how many zeros you will pad? 3 zeros. 3 bits will be padded. So how many bits to pad? It depends on divisor length. I hope you got it. Okay. I think Khan Bilal, you understood. Right. So meanwhile, anybody else having some doubts, you may ask. Shikhar was giving the answer as option C. Charu also C. Anybody else with the answer? So this is what given. And what is x cube plus x plus 1 means? 1 0 1 1. So we will first append 3 zeros. 1 0 1 1. We keep doing XOR. So it would be 1 1 1 and 0. Whenever MSB is 1, you can't shift left. So you have to do XOR again. So this would be 0, 1, 0, 1. And then this you can shift left and you borrow this one. So this would be 1, 0, 1, 1. So all zeros we got. So do 4 shift lefts and borrow 4 bits now. 0, 1, 1 and this 0. So 1, 0, 1, 1. Guys, I want code word. I don't want only reminder. I want code word, please. So this would be 1, 1, 1, 1. And as MSB is 1, shift it. You can't shift left. Do XOR again. 1, 0, 1, 1. So this would be 0, 1, 0, 0. So MSB is 0. So shift left and borrow this 0, guys. So here I am writing it 1, 0, 0, 1, 0, 1, 1. So it would be 0, 0, 1, 1. Only shift left only 1, 0 because you have only 1 left here to borrow. So this would be 0, 1, 0, 1, 1. 1, 1, 0, 1. Guys, if anybody are not getting, just follow, observe what I am doing. MSB is 1, so you can't shift left. So do XOR again. 0, 1, 1, 0. So as MSB is 0, shift left. Are there any more bits to borrow? No, there are no more bits to borrow. Here we will end. So what is the remainder we got? 1, 1, 0. And what is the code word? 0, 1, 0, 1. 1, 0, 1, 1, 1, 1, 0. Okay. Let's see. Okay. Anywhere did we do wrong? Okay, here it went wrong. Yes. 1, 1, 0, 1. Yes. So this would be 0, 1, 1, 0. Wait a minute. So this would be 1, 1, 1, 0. So not, yeah, 1, 1, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1, yeah. Yes, guys, not 1, 0, 1. This would be 1, 0, not 1, 1, 0. This would be 1, 0, 1. 1, 0, 1. Yes, yes. So you can see option C is correct. So this is the model question that you can expect in NIELIT. Guys, I know now it is taking some time, but you are having, guys, as you have 120 questions, 180 minutes, and there is a negative marking. Let's say you are attempting some 160 questions also. 120 minutes of time you have. Sorry. 120 questions, 180 minutes you have. So even if you attempt 100 questions also, you have 180 minutes. So you can say like 1.5 minute you can spend. 1.5 minute you can spend on your question in max. But if you practice this, if you practice this in 1 minute, you will be able to do this. But this is the question which you already got, guys. Okay, right. So the other questions are from Hamming code. So we will see that before. Yeah. So cyclic redundancy check procedure is this. And guys, in this CRC, what is the important point? We can say that divisor is represented in polynomial form in the powers of x. Let this be g of x. Let this be a function g of x. Then for this CRC to work effectively, some conditions are given. In that, let me give you some important conditions. To detect all odd number of errors, if this CRC procedure should work effectively, then it should detect if 1 bit changed, 3 bits changed, 5 bits changed, like odd number of errors. Similarly, for even number of errors also, means 2 bits changed, 4 bits changed, or so on. So for odd number of errors to detect, what are the conditions? Means it should not be divisible by, it should be divisible by x plus 1, and it should not be divisible by x. So whatever the g of x, that means in binary we are taking 1 0 1 1 1 1 0 0. Like if you convert it into decimal, it will be around like 12, 13, 15, whatever the value. That should not be divisible by x plus 1. What is x plus 1 means? 1 1, that means 3. Similarly, what is x means? 1 0, that means 2. So whatever the divisor we are taking, that should not be divisible by 3, that should not be divisible by 2, but divisible by 3. So this is the basic rule for detecting odd number of errors. And to detect even number of errors, we have some rules. To detect even number of bit errors, we have some rules. Like first rule, we can say that as there should be odd number of terms. Means you cannot have 4 terms or 5 terms or 4 terms or 6 terms or 8 terms, like that. You should have 3, 5, 7, the number of terms in the divisor as odd number. This is first rule. And the second rule, you can say the x power 0 coefficient should always be 1. That means compulsory it should end with something plus 1. This plus 1 term should always be there. Similarly, you can say the CRC divisor should have more than 2 terms. You cannot have 1 term, as because odd number of terms I said, you can't have just 1 term. You should have more than 2 terms. Like this, guys, there are some rules. When all these rules are followed and a divisor is formed, that divisor works for odd errors as well as even errors. So as there is much difficulty in applying all these rules and framing a divisor, we have got some standard divisors. Like some standard divisors as CRC 8, 8-bit divisor, CRC 10, 10-bit divisor, CRC 16 and CRC 32. Basically, these are the standard divisors we can say. Now, this CRC 8 and 10 will be used in ATM networks, not ATM centers. ATM is again a standard like OSI, like IEEE standard. ATM is a standard. In ATM standard, CRC 8 or 10 is used. 16 is used in a protocol called HDLC. 32 is used in Ethernet. This is important, guys. Why I am giving this information means there is a possibility of asking what CRC or what is the CRC divisor, what is the CRC reminder that is used. CRC divisor, sorry. What is the CRC divisor that is used in Ethernet? So CRC 32 is the divisor that is used in Ethernet. These are the some standard devices. Okay. I hope you got about this CRC at least some information. Those who do not know anything about it, I believe with this you got some idea. Okay. So try to explore more about this, guys, when you find time. Of course, you have to find the time for preparation. And the one who have prepared already, CSE students, this is a gate topic. So you might have prepared already about this in depth. So again, revise once. Okay. Now, these are all VRC, LRC, CRC and checksum. VRC, LRC, CRC and checksum. What these are all? These are all error detecting codes. So they cannot find which where the error is. They can only find whether error is there or not. So that's why we have got one technique called Hamming code. Hamming is the name of the scientist who invented it. This is a error detecting and correcting code. Detecting and correcting code. That means what Hamming code do? It will find the presence, whether error is there or not, and how you can correct, how you can correct. If you find which bit or how many bits are errors, that means it will find the position of error also. So how this will be done? How the Hamming code will be able to find the presence as well as position, we will see in the next class, guys. So this is, I have already prepared the examples for you to explain this Hamming code, as we stuck with this CRC. I think we took little time on this CRC, so I could not explain this. No problem, guys. We will continue the same in the next class. I mean tomorrow. Once this Hamming code is over, then I'll present. Here you can see questions are there from the Hamming code. So we have questions. So we will solve these questions. Then we will move on to the next topic, that is IP protocol header. From this also we have got questions in NIELIT, guys. We have got questions from this topic also. So once we complete this Hamming code, then we will be discussing about this IP protocol header format. Okay. So stay tuned to this, guys. And let me answer some questions. Shanmuga, is this series free? Yes, this is absolutely free series. Saurabh, dear, we need more classes, so please like. Yeah, Saurabh, that's what I said. We are trying to give you the best according to the time possibility. If time permits, definitely we will give you even more. Okay. Shanmuga was asking, are there any separate vacancies for ECE people? No. Shanmuga, it's not divided like that. These are common vacancies, common notification. This is for both CSC and ECE. Okay. Shikhar Saxena, sir, do you have any idea about expected date of written examination? Shikhar, like I cannot give you the accurate date because that will be known to only NIELIT, but I can say like maybe probably the exam may be in the June mid of June to July first week. This is my prediction. This is completely my prediction, guys. So maybe from June 15th to July 1st week, exam possibility is there. But as due to this corona, all are getting postponed. Its effect, if it is there, can't be said. But this is my prediction from the mid of June to first week of July. Okay. Right. So guys, we will be looking at this Hamming code followed by this IP protocol header format in the next session. Before you sign off, guys, as you may know or you may not know, at our Gradeup there is a provision called green card with which you can access all mock exams, all mock tests. You will have access to all mock tests, and currently a Dhamkedar, offer is Dhamkedar, the deal is happening where you can save 100 rupees off is running. So please try to get this green card access, guys. Okay. And then before I sign off, guys, about this corona again, please don't be panic. Don't be panic, guys. Just take safety steps. Just take safety measures. Stay at home. Stay healthy. Keep washing your hands regularly at regular intervals of time. Don't touch your face with your hands. So as you all know, just try to implement them, but don't be panic. Don't panic others also. So stay at home, stay healthy, stay tuned to Gradeup, guys. We will be always there to help you out. So see you guys in the next session with more interesting topics and more interesting stuff. Till then, keep preparing. Good night, everybody. I am signing off. I am Satya again. Prep smart, score better, go Gradeup. Thank you, guys.